My topic is called Learn the Hard Way, Workload Isolation. So we had some failures in our environment, which led us to explore a lot of scenarios on workload isolation. So I've tried to speak around those areas. Now, when we talk about workload isolation, what are your different workloads, right? So like in a data environment, you can talk about different workloads. But if I talk about personally, what are different workloads, right? So suppose managing our grocery, finance, kids, learning, partner and family, taxes. So we all wish that we had like separate engines, like they could run automatically, not needing our own resources, right? We wish that was true, but like I don't have that good news for us, right? But like Azure Synapse can provide you some workload isolation tools, which are really beneficial when you are talking about data workloads. Okay. So just a brief introduction for myself. I'm a data engineer, primarily focused on the Microsoft stack. My basic skill set has been SSIS, SQL Server, and currently Azure Data Stack. So you can pretty much talk about like as the Microsoft environment has evolved, I also have evolved with the environment, starting from SQL 2000, DTS to now Azure and Data Factory. So I have been here for around 11 plus years. Uh, I try to call myself a curious data geek because I love to learn new technologies and whatever new environments are coming. And on a personal front, I like to trek and a bit of cycling. So moving on to different data workloads. So what are the different types of workloads that we have in our environment? So the primary workload that we talk about is basically ETL workload, where we are trying to move data, ETL or ELT, depending on which framework you are coming from. Is it big data or more structured framework? But our main sources are different APIs. Today's day we have social media and mobile related data, different log and sensor data. But our major primary workload is to move data from different sources to object storage, be it Azure Data Lake in Azure or S3 in AWS. So moving it to a block store and then finally moving it to data warehouse environment. So Azure Synapse in that case. So ETL workload is primarily the workload on top of which the rest of the workload are also dependent. Other than the ETL and ELT related workload, we have different business reporting, like KPI reporting and other sales, marketing data, those sort of different dashboards and business reports. We also have different ad hoc queries from like business analysts or like different analytic teams and those sort of stuff. Then also we are running machine learning and data science workloads to improve our products, to get more insights from our data. And finally, it's someone high up in your organization running specific queries to check some business performance. Now, these are primary different kind of workloads that we have in a data warehouse or a data lake environment. There can be tons of other different workloads, but these are the major workloads that we face on a day-to-day environment, right? Now, if I talk about amongst these workloads, which one should take priority? Shall it be the ETL reporting, CEO's query? So what should be the priority in this sense? Like if everything runs together, there are chances that it can be we can have performance issues and all, right? So what are the best way to like identify like what should be the primary ordering of these workloads? Any inputs, any guesses from anyone? Okay, let's try to move ahead. So quite obviously, CEO's query should be the first top priority, because if his query is waiting for resources for a lot of hours, obviously that doesn't make sense, right? And we can say the ETL and ELT workload should be the second primary workload, because on top of this data, all the other components are dependent, be it the business reporting, ad hoc query, or the ML or data science. So depending on the primary criteria, we can decide like this should be first, ELT should be second, reporting should be third, ML and data science can run parallelly with reporting, and ad hoc users, ad hoc analysts would be the least priority in this end. Basically, what we are trying to say is that boss should not wait. So boss's query should run when he is executing. We should have the results back. Okay, so to implement this kind of ordering and to ensure that the queries are not waiting in queue, to ensure that the environment is run smoothly, be it the ELT or the other workloads, to ensure that they run smoothly, we have different concepts in Synapse. The main three pillars of these concepts is like the main three pillars of workload management is workload isolation, workload importance, and workload classification. So I would try to go into a bit of detail on each of these, but like I'm not an expert, but whatever we have learned through our scenario where we had a lot of failure, I would talk about just brief about those scenarios. So when we talk about workload isolation means the resources are reserved exclusively for some type of workloads, and like different workloads can run parallelly with the limited resources that they are assigned. Okay, so these can be achieved by setting up minimum percentage resources parameter while creating workload groups. So we'll see how this can be configured a bit more in detail. But isolation basically talks about like ETL should not be eating up resources from uh, your CEO's query, or your business reporting should not be eating up resources from the ML and data science query. Like every workload can have its set of assigned resources so that it can run as per its own SLA and as per its own performance criteria. And they should not be creating roadblocks for each other. So the second important thing is workload classification. So we have isolated the workloads. Now, how do we classify like which one is an ETL workload or which one is a reporting workload, and what should be the importance of that workload? That can be achieved using classification. So classification supports both like older format where we had fixed resource classes for different users, and also the new format where we have workload isolation in workload groups, and we assign importance, and then we can control the resources that are assigned to each workload. And an association concept is workload importance. Like we talked about, CEO's query should be the primary and topmost criteria, or should have the highest importance. So you can assign that while creating the workload classification, and that basically will derive how much uh, how much importance that would be provided when a lot of queries are running queue, and whether it should be a first in first out, or any specific query can jump to the front of the queue because it is more important. Like if CEO runs in and runs the query, his query should be sent to the top of the queue. Okay, so let us explore a bit more in details. So I'll talk about resource classes. So it was an older format of doing a bit of resource, like a bit of assigning of resources to different projects. So resource class can be static and dynamic. Those are the main criteria. And then the main default resource class is basically dynamic, and it is the small RC. So static resource class is basically useful when we have fixed set of data and we need more concurrency. Then we can control that using static resource class. Dynamic resource class is important where we know the data is growing, and as the data grows, we will like to demand more performance from the environment. So in that case, we can have dynamic resource classes so that it gives importance to specific set of loads as the data also grows. So static resource class has different kind of sections like static resource 10, 20, 30, 40, 50, 60, 70. This is based on like how much concurrency slots will be assigned to the resource, like to the workload. In case of dynamic resource class, we have small RC, medium RC, large RC, and extra large RC. So this will be depending on as the data grows, like how much importance will be given. So small RC can have like capacity out from 3 to 25% depending on like how the data grows. Okay? Medium can grow from 10 to 25. Large RC should always like it would be in the range of 20 to 25%, but extra large always have 70% of your complete resource class. Now, specific resource classes take precedence over other resource classes. Like dynamic resource class takes precedence over static resource. So if any specific login is assigned both static and dynamic resource classes, then the dynamic one will get priority. And larger resource classes take precedence over smaller resource class. So if I have a login assigned with small resource class and also extra large resource class, then the extra large will take precedence. Any questions? Fine. I'm not getting notifications, so sorry, I missed some of the answers. But let's try to. Okay, so I plan to have some demo, but my Azure account is not working properly, and I could not set up the databases and demo in time. But I have some of the queries in the presentation itself. So how do we create and assign members to resource classes? So SP add role member can be used to assign a resource class to an user. So suppose we can create a login. We can create a login like large RC login, login a separate login for CEO, and then we grant access to the Synapse database or to the Azure Synapse environment for those logins. So we grant access to Synapse admin large RC, and we give access to the Synapse database to that user. So we map the user to the login, and then we give specific access to databases to the specific user. Similarly, we can create a separate user for login A and give access, and a separate user for like CEO's login, and then give access to the database. Now we can use SP add role member to assign the resource class to that specific user. Okay, moving on. Now moving on to the topic of workload isolation. So we have assigned specific resources to a specific user. That is fine, but how do we segregate, like what are the different workloads that are running? Like specific users can run different set of workloads. So how do we differentiate between different workloads? Okay. So workload isolation ensures fixed set of resources to different workload groups. So we can create different workload groups and then assign an user to the workload group, And when that user or that workload group is used to run a specific workload, like it can be ETL or ELT, or it can be querying from the database like reporting, or it can be CEO's query. So based on that, we can create separate workload groups for different data workloads, and then we can assign different set of resources to those workload groups. Like suppose we can create a data workload group for ETL or ELT data loads. We can call it as a data load group, or we can set up one workload group for reporting and one workload group for ad hoc users. Okay? And we can assign specific resources like 40% to ETL or ELT, 40% to reporting, and 20% to ad hoc. Like that, we can do specific configuration. So if we go to the syntax of how we create the workload group, so here you can see create workload group. This is the name of the workload group. So I'm creating one for data load and I'm creating one for data query. Now I can assign the resources. So how do we ensure that this workload group data load will at least have some set of resources assigned to it? It should not wait for resources to be available. So we can assign a minimum percentage of resource. It can be 30, it can be 10, whatever we think is enough for this load. But this will ensure that a minimum of 30% of available resources will always be assigned to the data load workload. Similarly, we have assigned 50% to the data query workload. So this ensures that at least 30% will be available to data load and at least 50% will be available to data query. Now the maximum that can be assigned is 100 in both the scenarios. We can cap this. If we want that data load should not cross 50, then we can just mention 50 here, and then the percentage of resources that would be assigned to the data load group will remain between 30 to 50%. Okay, so that way we can ensure it never goes into the territory of the data query group. When we have like maximum assigned as 100, then even though 30 is assigned to it and 50 is assigned to it, what happens with when we have some extra loads? What would be assigned to whom? So in that case, we won't be able to control it from here. So we can cap using the maximum percentage. If we cap, then even if extra resources are available, it will not come to this load, it will go to this load. So accordingly, we can do that. Again, request minimum resource grant percentage. So this is used to drive concurrency, like how many of data load queries can run parallelly. So this will be driven by this percentage value. So suppose we have assigned the minimum resource percentage to be 30, and if we assign the minimum grant percentage to be 5, in that case, basically we are saying at least 6 concurrency slots will be assigned to these workloads. Right? So suppose it will guarantee a minimum of 6 concurrency slots because it's taking 5% here and maximum is 30. So 5 into 6 is 30. So it can be guaranteed of minimum 6 concurrency slots, and then maximum resource grant percentage is 10. So if I have more resources available, then per concurrency slot granting will be higher. Again, we can assign the importance. So importance values can be low, below normal, normal, above normal, and high, depending on who is running the query, right? If CEO, if we have a separate workload group for the CEO, then we should mention the importance as high, so that that is assigned priority when multiple queries are in queue. There are some other parameters also, like query execution timeout. So how many seconds that the query should run before it gets timeout. So that is also to ensure that it doesn't eat up extra resources when basically the query is not completing in time. It is we can assign that value to ensure extra resources are available. So this is just moving on from what we actually said. So this next topic is like how can we use workload classification along with workload isolation, right? So for workload classification, we create different classifiers on top of the workload groups, and we assign workload groups to those classifiers to ensure like which job will run in which priority. So suppose here I am creating a workload classifier, classifier A, and so this is for the data load workload group. And I am assigning a member, like we created a user as Synapse large admin RC. So I am assigning the member to the classifier, and then I am assigning the importance. So we are assigning the normal importance. Some other parameters like we can have it run between specific time periods, start time and end time. We can add labels and context to run different loads, but I'm not going into those advanced set of things. So basically what we are trying to do is we are assigning a workload classifier to a specific set of user, and we are assigning the importance to it and assigning the workload to it. This classifier will then ensure how much resources will be available to the query that is being run by this user, Synapse admin large users. We are creating another classifier for suppose another user who is basically running it for running it like running query kind of workload. So for the query, we have set low importance because we want the data load to be a primary importance and this to be a bit lower importance. We have other options like below normal, normal, above normal, and high. Now talking to the CEO again, he should not wait. So that's why we have assigned this also as data query, because this is also a user query only. But again, this is assigned to the CEO, but this has got higher importance. So if I run these two setup, like if both user login A and user login CEO, so these two logins run a specific set of query, we can say like this will have higher resources and it will move on top of the queue whenever any queued jobs or query get executed, then this one should move up to the front and it should be executed. So that way we can ensure that it has some specific set of resources always assigned, and if I have multiple queries running, then it should move higher to the queue, and that should get executed first rather than the one with lower importance, which should move back in the queue and will be run later only when the high importance query is completed. Then only the lower importance query will get executed. So I have shown kind of visualization to clarify the same things. So suppose we have like 8 concurrency slots running, 8 concurrent jobs running, and then 9, 10, 11, 12, so 4 different workloads have come in along with the CEO. So if we don't set up any importance, then when 8 finishes or when any of the load finishes, suppose here if 3 finished, then 9, like first in, first out, 9 is first in the queue, so it will move and take the slot of 3 and it will get executed. Then obviously CEO's query will keep waiting, and angry boss is bad news. So so moving on, if we set up importance for the classifier, then when 3 completes, even though like 9, 10, and 11 are first in the queue, but because they are lower in priority, then CEO's query will take precedence and it will move back and it will be executed whenever 3 or any of these concrete slots get free, then CEO's query will get executed and other loads will get queued up. So that's the usage of importance of workload importance that we can configure. Now finally, I'll move back to the case study that I talked about. So This was the situation which led us to explore different isolations that was possible in Synapse. Like some other data warehouses have this as a default service, but Synapse it was relatively new, and we were not aware, so we paid highly for that. So in our case study, so basically, what is the worst nightmare for a data engineer or an ETL support engineer? So our worst nightmares is getting up in the middle of the night in an on-call shift when we get a message that like the loads are not running and all the queries are getting queued up, and like the different pipelines are either running very slow or failing with timeout issues and those sort of things. We don't want to be in that situation, but that's what happened with us. We had around 1,400 pipelines in our environment running smoothly with 1,500 DW units. But then we added up extra 26,000 table loads using Click Replicate. So this was for a data lake environment we are creating, and a lot of tables were needed to be replicated in Synapse as a raw layer. But like we didn't have workload isolation and workload management in place. So all the pipelines started getting slower. A lot of user queries were running for ages, and obviously even CEO's queries was impacted. Different data loads were not getting through, and all the users were complaining about not having proper data, not having data for reporting. Even several business stores started reporting that their performance is getting impacted because they are not able to track the KPIs. Now, what was the solution that we proposed? So we tried to stop the click loads to see if the performance improved. It was a bit better, so we thought probably then the resources are getting used up, and that's the issue. So we called up Microsoft for doing some debugging and all, and they suggested two approaches. They suggested to use DMVs to check query wait time and query queue time. There are different DMVs in Synapse available. You can go to Synapse documentation and check the different DMVs. Yeah, so this is used to detect queued up queries and all. So we can use these DMVs to see what's happening with our execution, what's happening in our environment, what are the queries that are waiting in queue, those sort of things. We can use the DM. So what we saw was we saw a lot of queries were getting stuck and were getting queued up. Okay. So we didn't have workload groups to isolate those data. So as a result of that, a lot of queries were getting queued up. So a quick question, can scaling down help you improve performance? Like we have always heard that scaling up can improve performance, but can scaling up also improve performance in any situations? Have any of you faced any such scenario? That's a good question. It can be a, sorry, I'm just taking up this question. How the CEO accesses a SQL pool in the first place is a direct query scenario. It can either be a direct query, it can be a report that he is running specifically from his side, depending on how much technical the user is. But basically, it's kind of it's just to explore a scenario where we have higher importance to a query. Like user login can be CEOs or a business analyst who is in a higher position, or it can be a extremely business critical report that is being run from a service ID. So those sort of things. It can be anything. No problem. So any scenarios where scaling down help you improve your performance? So since I don't see such scenarios, so let me move back to what happened to us. So why I am saying scaling down? So my answer is yes. So what was happening? It was a very intriguing scenario. So basically, because we had a lot of data loads, and a lot of them were just one-to-one copy. So they were not very complicated table joins. They were not very long-running reports. They were not very complicated SQL queries. The queries were very small, but we had assigned a larger resource class to the service account that was running the query. So as a result, what was happening, like every time it was trying to wait for that much resources to be available. We saw that whenever we have higher resource class, that means we get lesser concurrency slots. Okay? Because our TWU units are fixed, we are not going for dynamic scaling. So in that environment, if we are waiting for a larger resource class, then we are losing out on having multiple concurrency slots. So that means we cannot run a lot of loads or a lot of queries in parallel. So our parallelism is getting restricted. But because we were running a lot of data loads in parallel, they were smaller queries, but they were waiting for larger resources to be available. So as a result of that, when we ran the DMVs in our environment, we saw that a lot of queuing was happening. We also checked in the pipelines. We checked in Azure Synapse portal, and we saw a lot of queries were getting into queue state. The queue time was higher rather than the processing time. So what we did was we implemented workload groups, separate workload groups for separate workloads. Like I mentioned, we added 26,000 click replicate jobs, which were one-to-one replications. So we gave them a smaller resource class by creating a workload group, and we limited the percentage of resources available to just 20%. For our ETL workload, we kept 20% for lower importance workloads. So we assigned a minimum resource of 5 and a maximum capped resource of 20. So as a result, the click replicate job was now assigned only 20% of the resources max. Our lower importance jobs were also given only max 20%, and higher important jobs, higher important data loads, which required higher resource classes, were given higher resource classes and a greater percentage of the resourcing. Now, because we decreased the resource class and gave a limited set of resource percentage, so what happened was like different set of workloads were not eating up each other's resources. That was the first thing that happened. And the second thing was because we decreased the resource class, we increased concurrency slots. We got a lot of free slots. We were able to run a lot of jobs in parallel, and a lot of smaller jobs which were actually getting queued earlier finished in microseconds and in seconds, because now they are actually not waiting for higher resource classes. They did not need to wait for higher resource classes. Even with smaller resource classes, they were able to execute quite fine. So it was a multi kind of approach. So we implemented workload isolation using workload groups, where the data load and where the click replicate, the data load and the reporting were separated out using isolation, and their set of minimum and maximum capped percentages. So they didn't eat up resources from the other class, and also using lesser resource classes for smaller queries and higher resource classes for complicated queries. So that way, even parallelism increased both in smaller queries and both in higher queries. So we are able to run a lot of things in parallel. That made our boss happy, that made our lives happy, because we didn't have to get up in the middle of the night to resolve resourcing issues and to resolve different failed data pipelines, to rerun them. And basically that's how we learned about these facilities available. Obviously, there's a lot of things to go into in detail in each of these area. A lot of different DMVs are available from Microsoft to analyze the performance of different parallel running queries. Also, there is a stored procedure that can be used to basically have an idea of what resource class can be assigned to a table. Just trying to find out. I think this is how, yeah. So this is the stored procedure that can be used. So identify like what should be the uh, best resource class for a sort of table and with the kind of DW unit that you have. So that gives some idea. So a lot of things to go into detail. Also, if someone wants, they can explore the Microsoft documentation. So I just tried to have an understanding of the scenario that we had and how we learned from the difficult scenario that we faced.